Welcome to another practical physics walkthrough from Godalming College Physics Department. Today we're going to be looking at the Young's double slit experiment. Quite a complex setup, a relatively tricky experiment to perform, but will really test you to see if you can take and record careful measurements and be able to analyse these and compare them to a known value. This particular experiment obviously will give you all the instructions you need and all of the theory behind it, but it is something that's a bit tricky, so I strongly recommend that you go over to Antonine Education or look in the textbooks to have a look at the process of interference and specifically the look at two-source or double slit interference. Whole wad of information. It would be a really good idea for you to have a little look. It's got this exact experiment explained, and although this is shown on a screen and we're actually going to be looking at it through a telescope, it does explain exactly how this experiment works. Even without this video, this script does give you quite a lot of detail. It is a tricky experiment to set up, and in actual fact we give you the optical bench with the eyepiece, slits and single slit already set up. The sodium lamp you're going to need to get from the prep room, and here's an important thing. Get the sodium lamp right at the start of the lab and turn it on straight away. The more it warms up, the better the results you'll get. That image with the W is what we're going to see in a moment through the eyepiece. I'm actually going to show you in this video what it looks like. And the formula is actually a relatively simple one, if I'm going to be honest. In theory, you'll learn how to derive that formula, but for now, all we're going to do is just use a bit of y equals mx plus c to work out what the wavelength of the sodium light is. So, let's have a little look at the setup. Forget the webcam, we're going to be using that to look through the eyepiece in a moment. But what you can see is we've got a sodium lamp with an optical bench in front of it. We've got a travelling eyepiece, which I'll talk about in a moment. We've got a single slit, and in between those we've got a set of double slits. This travelling eyepiece is basically a telescope with a micrometer gauge on the right hand side. So as you rotate it, the screw moves the eyepiece left to right. And you can look at the gauge and you can see how far left to right it's moving. When you're using that gauge, please be careful. If you overscrew it, then it will either fall off or just go off the end of the scale and be a real pain to fix. If we look at how we set the experiment up, you can see that we've placed that single slit directly in front of the sodium lamp, and if you look through that you'll be able to see where the brightest point is. If you then bring the double slits in front of it, you'll actually see the yellow light being shone onto the double slit. And ideally that yellow light is shining absolutely in the middle of the etched slits that you can see. Try and keep your fingers off those double slits, please. You've then got to know that they're absolutely in line, so you can start to move them apart knowing that at least everything's lined up. Moving on to the eyepiece itself, if I take out the telescope and actually have a little look through, you can see that we've got a set of fine cross wires or crosshairs. The telescope allows us to focus either onto the crosshairs but still see the light. Here you can see me adjusting it and you can see it moving left to right. So if we look through this using the webcam, you can just about make out the bright and dark fringes. Let's do this with the lights off and you can see really clearly. Depending on how far away you are, depends on how many fringes you'll be able to see. You can, at the bare minimum, see 3 or 4. If you're a bit closer, you may be able to see as many as 20. You can see I'm now adjusting that micrometer style screw gauge, and as I rotate it, you can see the crosshairs moving to the left. So what you can do is you could line up the crosshairs on one edge of a fringe and you can move it as many fringes to the left as you possibly can, let's say 8, and you could look at the difference between the two positions on the screw gauge and you will be able to work out the difference so the distance across 8, and therefore you'll be able to work out the distance of 1, which is the value W you can see behind the video on the lab script. Here is a suggestion for how you might want to record your results. At the top, we've got you marking the double slit position, which you shouldn't move. Then we've got a series of columns. On the left-hand side, you've got the eyepiece position. You're going to do this experiment for several different distances of eyepiece. Obviously, eyepiece position minus double slit position will give you the value of D. You're going to need that to stick into the formula. Once you've got that, you've then got two values, the left hand and the right hand reading of the screw gauge from the travelling eyepiece. Ideally, you'll go to the leftmost fringe and then move across several fringes, say however many you can do, to the rightmost fringe, making sure you're always sticking to the same edge of both. And of course, left hand reading minus right hand reading gives you the total distance between the two readings. If you've got 10 readings, you divide it by 10, and that will give you your value for W. Once you've got that, move on to another distance D and repeat again. When you're measuring these, just be careful that you're using the same edge of a fringe. So if you start on the left hand side of the leftmost fringe, you then go to the left hand side of the rightmost fringe. So in this case, we've got 1, 2, 3, 4, 5 W's. Just be really careful that that's what you actually count. If in doubt, go back, do it again, because if you miscount, you're going to get really bad. So I hope this video has given you an overview of how to set up the experiment and a few hints and tips about how to conduct it in a way that will give you a best chance of getting some results. I've not covered the analysis of this at all. I might do another video to help you with that, but hope you found this useful and enjoy the lab.